Welcome back to All This Math. This is Professor Parker, and for this lesson, we're going to do some work on factoring expressions. Factoring expressions. Now, before we get started on these two examples up here, let's talk about what factoring expressions even means. So we have expressions that include numbers, coefficients, variables, exponents, what have you. When we take those expressions and we break them down into smaller pieces, pieces that have a lower degree. So when I say smaller pieces, I mean so if you got expressions that got bigger exponents and you break them down into expressions that have smaller exponents, that's what we mean, right? So that's what we're going to do with this one, and we're going to do the same thing with this one, all right? Now, there are many different ways to factor expressions, but when you look at an expression and your job is to factor it, the first thing you should always try to do is to look for a GCF. Now, GCF is an acronym. You might have heard of it before. You might have heard of it and just not know what it is. GCF stands for greatest common factor. Greatest common factor. All right. Now, what you do is you got to look at your coefficients first, and then you look at your variables. Well, it really don't matter what you do first, but you got to look at your coefficients and you got to look at your variables. Now, what are your coefficients? I know I'm throwing a lot of terminology at you. The coefficients are the numbers that tell you how many of the variable you have. So there's no number written in front of y to the fifth power. So that means I got one of them. Whenever there's no number written in front of the letter, that means the coefficient is one. That means you have one of them or one of that thing. So how many y to the fifths do I have? I got one. If there was a 2 in front of here, that would mean I got 2 of them. If there was a 5 in front of here, that would mean I got 5 of them. But if it's no number, that's understood to be 1. That means we got 1 y to the fifth. Now look at this one. I see a 9 right here. That means I got 9 of them. 9 y to the third power. That's how many y to the third powers I got. So you got to ask yourself, what is the greatest common factor of 1 and 9? 1 and 9. The greatest common factor of 1 and 9 is 1. 1 is the biggest number, right, that they're both divisible by. 1 divided by 1 is 1, and 9 divided by 1 is 9, right? They're both divisible by 1. We can't say 3, we can't say 9, because if you do 1 divided by 3, you don't get a whole number. If you do 1 divided by 9, you also don't get a whole number. 1 is the biggest number that they both can divide into. All right, so now that that's taken care of, keep that to the side. Now look at your variables, y to the fifth and y to the third. Now, when I was coming up, I was told that when you look at the variables, first of all you got to do is look for variables that match up. So if I see a y right here and I see a y right here, I'm like, okay, cool, bet. I know that's going to be part of my GCF. And then you got to look for the exponent that's smaller. Then you just got to look for the smaller exponent. So I see a 5 and I see a 3. 3 is less than 5. So I know my GCF out of the variables is going to be y to the third, right? I just memorized that when I was a youngin', right? But I recently came across this other way to look at this, which is this. If I see y to the third right here, and I see y to the fifth right here, and I know my exponent rules, namely the multiplication rule for exponents, I could break this y to the fifth down into 2 separate parts. And one of the parts will be a y to the third, so you'll have y to the thirds that will match up. But if I got one part as y to the third, the other part got to be a y squared, because 3 and 2 gives you the 5. So this is what it looks like. Imagine this was like, instead of being y to the fifth, this was y to the third times y squared. And then that was plus 9y to the third. So now when I'm trying to look and see, okay, well, what's my GCF? Now it's easier to tell that y to the third is my GCF. Because look, this term got a y to the third in it, and this term got a y to the third in it. And like I said, I just learned about this recently. This is just another way to look at it. Like I said, years ago, probably 30, almost 35 years ago, when I first learned how to factor a quadratic expression, all I was told was, listen, look for the variables. If it's more than one of the same variable, like in this case, we got more than one y, we got a y right here and a y right here. Y is going to be one of your GCFs or part of your GCF. And then you take the y that's got the smaller exponent. But I never really understood that this is another way to look at it. And that's cool. I learned something new. So you're never too old to learn a different way of looking at an algebraic problem. All right, so now we knew that from the coefficients 1 and 9, 1 is part of our GCF. But when you write 1, you don't need to write it when it's the coefficient. But then you say, okay, well, I got y to the third here and y to the third here. So my GCF is just y to the third. That's my GCF. My greatest common factor is y to the third. Now, how do I finish it? The first step is to find the GCF. The second step is to divide by the GCF. Again, first step is to find the GCF. The next step is to divide by the GCF. So what you do is you write it like this, y to the third. Next to the GCF, you're going to write a set of parentheses, an empty set of parentheses. At least this is how I do it. And then you got to figure out what's going to go inside the parentheses using the second step. Divide by the GCF. So each term in the original expression is going to get divided by the GCF. All right? So you're going to do y to the fifth divided by y to the third. Then you're going to do 9y to the third divided by y to the third. So it's going to look like this. Y to the fifth divided by y to the third. Now, you got to know your exponent rules in order to do this. You got to know the division rule for exponents in order to use this method. The division rule for exponents says that when you got the same base, in this case, y is your base here and y is your base here. You can subtract your exponents by doing the top exponent minus the bottom exponent. So 5 minus 3. So it's going to look like this. You write y one time, and then your exponent is going to look like 5 minus 3. Then you're going to actually do the subtraction. And we know that 5 minus 3, because we remember our subtraction facts from way back in the day, 5 minus 3 is 2. So we're going to have y squared. So that means that y to the fifth divided by y to the third is y squared. So then you take that y squared, write it inside the parentheses right here, just like that. Like I said, first step, find the GCF. That's this right here. Next step, divide by the GCF. We just divided by the GCF, but you got to divide everything by the GCF. So now we're about to do 9y to the third divided by y to the third. So we got 9y to the third divided by y to the third. Yeah, okay. Now, when we do division, you got a coefficient up here. You want to divide your coefficients and then divide your variables. Divide your coefficients and then divide your variables. So first you say, well, what are my coefficients? I got a 9 up top and I got a 1 down the bottom. So I got 9 and a 1. 9 divided by 1 is 9. Now, how do I know it's a 1 there? Because there's no number written in front of the variable. Whenever there's no number written in front of the variable, that means that the coefficient is 1. That's what it means. All right? So you do 9 divided by 1. 9 divided by 1 is just 9. So you write your 9. And then y to the third divided by y to the third. What happens whenever you divide something by the same exact thing? Whenever you divide something by the same exact thing, the quotient, which is the answer in the division problem, is 1. The quotient is just 1. So that means that these y to the thirds basically cancel out, leaving you with just 9 times 1, which is just 9. So that's what you're left with. And that's a positive 9. Right here, positive 9. So I'm going to put that in the parentheses, and I'm going to have plus 9. Y to the third times the quantity. That's how we say that out loud. We call it a quantity times the quantity of y squared plus 9. All right? Now, we look at this and we say, okay, well, we check it to make sure I can't factor no more. Now, if this was a y squared minus 9, then we could factor this another way, right? That's what we could do. Because there's a special type of factoring called, well, at least some people call it DOTS method. DOTS is another acronym, just like GCF is an acronym. DOTS is an acronym which means difference of two squares. That's what DOT stands for. And there's a specific way to factor binomials that are a difference of two squares. But this ain't a difference, though. This is not a difference. This is a sum. When you see the plus sign, you know it's a sum. All right? When you see the minus sign, that's a difference. All right, even though these are both perfect squares. Y squared is a perfect square and 9 is a perfect square. But this particular problem is finished. This is finished. This is completely factored. Y to the third times the quantity y squared plus 9. All right. Now, slide over here to number 2. We got y cubed or y to the third minus 3 to the w. I'm sorry, minus 3W. 3W, not 3 to the W. Minus 3W. I misspoke. All right. First thing you want to always do when you factor is look for a GCF. Always look for a GCF. That's a good habit to develop. Because what'll happen is if you try to jump to another type of factoring, it's like 5 or 6 types of factoring when we deal with like quadratic expressions, cubic expressions, you know, no matter what the exponent level it is. Sometimes you might see like a trinomial expression with 3 terms in it. You might automatically jump in and start trying to, you know, factor it a certain way, not realizing that there's a GCF. And usually what happens is if you don't take out the GCF first and do what we did over here, you're making the work harder for yourself anyway. So you want to pull that GCF out so you can, like, you know, reduce the value of the numbers in the expression anyway. That's what you want to do. So do yourself a favor, always check for a GCF. Now here, check for a GCF. I see this got a W and this got a W. You take the W with the smaller exponent. But also, like I said in the other problem, look at your coefficients. I see an invisible 1 right here. So that's what I'm going to do. I'm going to put a 1 right there in blue so you see the difference. Like, that wasn't originally written there because you don't need to write that 1 really. I see a 1 and I see a -3. When you got a 1 and a -3, the GCF of those is 1. It's just 1. So out of your coefficients, your GCF is a 1. And then out of your variables, your GCF is a W, because that's W to the first power, and that's W to the third power. But we could rewrite it like this, and we could say W squared times W minus 3W, because the multiplication rule for exponents says that when you multiply variables, you add their exponents. So if this exponent is a 2, and this exponent is a 1, which isn't written, 2 plus 1 gives you 3. So this is equivalent to this. This is equivalent to this. The product of these two is equivalent to this. So I got a W and I got a W. So that's what they got in common. They got it in common because they're in the same, it's in both expressions, the W. All right. But another way to look at it is you take the W with the smaller exponent. So this got an exponent of 1. This got an exponent of 3. 1 is less than 3. So we rock out with W to the first power, or just W. So what you do is you say, okay, my GCF is just W. All right. And then you're going to write W, and then you write your parentheses. So you find the GCF, then you divide by the GCF. You find the GCF, then you divide by the GCF. I should get a t-shirt with that on it. That's what I should do. Yeah, I think I will. Find the GCF, then divide by the GCF. All right. So now I'm going to do W to the third. In fact, I'll write it right here. I got room. W to the third divided by W. Again, division rule for exponents. Division rule for exponents. We don't got to worry about the coefficients because they both 1s. They invisible 1s. 1 divided by 1 is just 1. So we don't really worry about all that. W to the third divided by W is really W to the first. So what do you do with the exponents? You're going to subtract them. So that's a 3 minus a 1. So this looks like this. W to the 3 minus 1 power, which is W squared. So that's W squared. So where I put the W squared, you're going to put it inside the parentheses like this. And then you're going to do, remember, find the GCF, then divide by the GCF. Find the GCF, then divide by the GCF. So then what you're going to do is you're going to take this negative 3W. Don't forget it's a negative because of the minus sign. Negative 3W divided by the GCF. Now the coefficients, right? This is a -3. This is a +1 coefficient, right? -3 divided by 1 is just -3. So that's going to at least be part of your GCF. Then you got W divided by W. Now again, what happens when you divide something by the same exact thing? What happens when you divide a number by the same number? What happens when you divide a variable by the same variable? Your quotient is always +1. Unless you're doing 0 divided by 0, which that is undefined, or it's either undefined or it's infinity. I'm not sure. I need to look that up. But I'm pretty sure it's undefined. But we deal with that in calculus, right? So the W divided by the W is going to be a 1. So that's just -3 times 1, which is just -3. That's all that is. So this -3 is going to go in here. So this is going to be your final answer. And I know it's my final answer because I can't factor this w squared minus 3 any further. If this 3 was a 4, and that said w squared minus 4, I'd be able to factor that further because it would be dots. Difference of two squares. Difference of two squares. But it's not, though. All right? So I hope that made sense. That is very important. These examples are very important. And what we went over in terms of finding the GCF when you're factoring, because that's like the first type of factoring. That's like the first line of, factoring, right? So when you're factoring, you got to know how to find the GCF before you even get into the other methods of factoring, which you will encounter if you're dealing with cubic expressions or quadratic trinomials or four-term polynomials. There's some other different methods of factoring, but the first method you should always try to employ is finding the GCF. And remember the two steps. Find the GCF and then divide by the GCF. Every original term gets divided by the GCF. You take those answers and you put them into the parentheses. Here, GCF was W. Then you divide each term by the GCF. Put those answers into the parentheses. And here's another thing. You got to get some practice now. I showed you how to do it, right? But now you got to get the practice. A lot of people don't excel in math, not because they lack understanding. It's because they lack practice. They don't have enough repetition. They don't practice on their own. They don't get down, roll their sleeves up and get their hands dirty, make their mistakes and work through the mistakes so they can also remember how not to do it. It's not enough just to watch a video and then go on about your life. You got to watch a video if you need to, and then get some practice problems. With these, go do 10 or 20 of them, right? Until you commit it to memory, all the steps, and then do different types of problems that look different ways. Practice your division rule for exponents, all of that. That's what you got to do, all right? So, yeah, go get some practice. Use this video as a guide, and I'll catch up with you on the next video, all right? Y'all be easy.